Hey, good afternoon, everybody, and thank you for attending this webinar today. Um, we had a lot of people register for this webinar. I think many are just going to get the recorded version, but for those of you who are here live for the presentation, I greatly appreciate that. I see some very familiar names on the list, so I'm very grateful that you would attend. So this is a very important subject, nutritional medicine and Parkinson's disease, for a number of reasons, which I will outline. So let's get right into it if we can. So the premise of this webinar is that as good as medical management is for Parkinson's disease, it doesn't really cure the disease, and it doesn't really stop its ultimate progression and demise of the patient to the extent that is possible, according to the available human clinical trials that we have, and also anecdotal reports, which I'll share with you. The role of nutritional medicine is important, and it's often ignored in medical channels. But exercise therapy and some targeted nutrients can go a long way to improve the management of Parkinson's disease. And I will tell you that I think it can play an important role in the prevention, which we will also talk about in some detail. So I'll show you that research and give you the scientific references to support it. So the overview of this presentation, which I have to go through fairly quickly because we only have a short period of time, is we'll quickly look at the incidence and the pathophysiology of how this disease develops and how common it is. We'll look at, I'll sort of outline the genetic factors that people can inherit that can cause a disease, but only in 10 to 15% of cases is Parkinson's disease an inherited condition. In 85 to 90% of cases, the person you develop it due to damage that occurs over your lifetime, and I'll show you how that happens and how you can likely prevent it. We'll look at the medical management, and then I'll show you where the disease process can be affected by nutritional medicine, the different factors that are involved concerning CoQ10 and glutathione and the age-related decline in dopamine and dopamine signaling, the role of energy in the brain and how creatine can be helpful, and other nutritional lifestyle practices that have been shown to be very important. And I'll highlight some of the clinical studies that we've seen along the way. So it's not just experimental. We're talking about humans that see a benefit. Clinical trials have demonstrated that, unfortunately, neurologists seem to ignore almost everything I'm going to show you. It's shocking to me. But Parkinson's disease, in terms of its incidence, it's a very common problem. I think the bottom line here in Canada is that as people get older, 1 in 500 people develops the disease. That's a lot of people, 1 in 500. So I know everyone on this call has known someone who's been affected by Parkinson's disease. So these people need your help. And I say that because often I look at what naturopaths are doing to manage the disease, and sometimes they miss some key components that I'm going to show you today. So in terms of the basic pathophysiology of how this develops, things you already know, there's a loss of the dopaminergic neurons in the part of the brain called the substantia nigra, part of the basal ganglia. And so it coordinates movement and coordination and muscle tone, and it helps to smooth out normal body movements, as you know. So you need dopamine, otherwise you run into trouble. And as these nerve cells die off, eventually you get into rigidity and spasticity, slowness of movement, all those things that you see. So just as a quick review, the red and the green pathways here are the dopamine nerve pathways in the brain, and they extend to many, from the basal ganglia, it extends to many parts of the brain, including the ventral tegmental area, the nucleus accumbens to the cerebral cortex. There are links via the thalamus to the spinal cord and ultimately to peripheral muscles. So a lot of things can become affected when you have the basal ganglia dysfunctioning, including the link to the thalamus and then to the motor cortex, and you start to get movement problems and tremors and spasticity because without dopamine, this coordinated movement and normal muscle tone is greatly compromised. So when do the signs and symptoms of Parkinson's actually appear? Now, this is what's shocking, and that is that by the time the first tremor occurs, 60 to 80% of all the cells in the substantia nigra are already dead. So by the time they had the first symptoms of the disease, you already have extensive nerve loss in that part of the brain. So the goal is to help to optimize the cells that are still functioning in the substantia nigra, try to keep them alive and prevent further degeneration, and help to prevent as best you can Lewy bodies from forming, which is the accumulation of a toxic protein called synuclein. As it accumulates, it can lead to Lewy body dementia, as you probably know, and affect cognition. What causes the cells to die? It really looks, and everyone sort of agrees with this now, that free radical damage to those neurons is really at the heart of it, as well as some other factors which, with respect to mitochondrial dysfunction and lack of mitochondrial biogenesis, but it all tends to stem from a lot of reactive oxygen species, which I will show you. So in terms of the disease progress, early in the disease, of course, you have involuntary tremors and slowness of movement, difficult walking, and then it progresses and it can lead to behavioral changes and dementia and depression. And so at the heart of it, the basal ganglia, as it becomes dysfunctional, you get all of these outcomes, including in the later stages, problems with autonomic dysfunction, sleep disturbances. Of course, depression would be a likely outcome from this, and cognitive impairment, especially if Lewy body dementia occurs. So this is what Lewy bodies look like. It's an accumulation of the alpha-synuclein, sort of a toxic protein that accumulates in nerve cells, and it causes cell death, but it also leads to dementia, which can include hallucinations. So there's a sporadic form, which is like the most common form of Parkinson's disease. It occurs in people that don't have any genetic inheritance for the disease. They don't have the genetic risk factors. It's due to environmental and lifestyle factors, mostly, as we'll talk about. But 10 to 15% of people who have Parkinson's disease, it's because they inherited these different genes that are already defective. And a lot of those genes are affecting the integrity of the mitochondria and that part of the brain. When the mitochondria doesn't work, the cells can't make energy, free radicals are generated, and it leads to all the consequences that I'm going to show you. Sometimes the genetic mutations are linked to increased accumulation of synuclein, which is, that's a really tough inheritance to acquire, because there really isn't any known way to block that at this time. But where you can have an effect with your patients in terms of prevention and improvement of the management is to help to improve their mitochondrial function, try to preserve their dopamine transport function, which I'll show you, decrease free radical damage to the cells, and a lot of that has to do with increasing glutathione status, but that's only part of it. But we'll get into the details of it. In terms of the majority of Parkinson's patients where you can be more highly effective, understanding where this sporadic environmental Parkinson's disease comes from is very important. So we see that it seems to come from 4 different places. The first is a defective complex 1 cytochrome in the mitochondria. So of course, and we'll review this, but as the mitochondria is generating energy for the cell, the first step of that, as complex 1 has to donate the hydrogen electron to complex 2, and if that gets blocked in any way, then you can't transport the electrons down the mitochondrial chain. You can't make ATP energy. And also the electrons are now leaking out of the membrane because they're not going down the cytochrome chain anymore. They're reacting with oxygen in the cytosol of the cell, generating all these reactive oxygen species, which cause massive free radical damage and mitochondrial damage to the membrane of the mitochondria. And this leads to cell death. So preserving the complex 1 of the mitochondria is critical for prevention of Parkinson's and in the treatment of Parkinson's disease. The second thing is the accumulation of mitochondrial DNA damage. So mitochondria have their own DNA. The cell has its own DNA for replication purposes, but the mitochondria is like its own little cell within a cell. There's mitochondrial DNA, and that mitochondrial DNA can become damaged over time by free radicals. And when that happens, the mitochondrial membrane starts to leak electrons out, and you get more reactive oxygen species. And the mitochondria can't replace itself normally. So the brain cells don't really replace themselves, but the mitochondria within your brain cells do replace themselves. You can have new mitochondria for the rest of your life, and that's the energy factory of the cell. And if the cell's making the energy that it needs, the neuron's probably going to be functioning quite well. But certain things can impair the ability of the mitochondria to replace itself, what we call mitochondrial biogenesis, leading to mitochondrial dysfunction. And when that happens, you have old, worn out mitochondria that can't generate energy very well. And this is where some natural agents like coenzyme Q10, alpha lipoic acid, and glutathione play a role. All three of those molecules are conditionally essential nutrients. That means that as we get older, our body makes less of those protective nutrients, and now the mitochondrial membrane becomes greatly compromised. And complex 1 in the mitochondria needs coenzyme Q10 to shuttle the hydrogen electrons down. So these three molecules, CoQ10, alpha lipoic acid, and glutathione, we're going to feature these in a moment, play a critically important role to allow the mitochondrial membrane and cytochromes to function normally. You have normally functioning mitochondria in your nerve cells, you're probably going to go the distance in life in terms of brain health. Some people are born with genetic glutathione polymorphism. That means they don't make the glutathione S transferase enzyme very well. And what you're going to see is that when dopamine gets broken down by MAO enzymes, it forms these free radicals in the forms of these quinones, and these quinones can do a lot of nerve cell damage. So for normally, when dopamine gets broken down, those of us who don't have this genetic polymorphism of glutathione, our glutathione that we're making can quench those free radicals before they do nerve cell damage. But in people who have glutathione polymorphism, where they don't make the glutathione enzymes very well as an antioxidant, those dopamine quinone free radicals accumulate as dopamine gets broken down, and it causes tremendous free radical damage that leads to cell death and also stimulates the production of synuclein protein. So in those patients, it's helpful to give them glutathione precursors, which we'll talk about. And I have seen personally, if you give them an IV of glutathione every couple of weeks, how it really helps to manage the condition. But that's another cause of Parkinson's that's sort of under the surface. And then for all of us, as I will show you, there's not only an age-related decline in CoQ10, alpha lipoic acid, and glutathione, but we make less dopamine as we get older, and our dopamine signaling starts to decline. And there are ways that you can counter all of these things through nutritional medicine and lifestyle interventions. So that's important for prevention. But it's also important in the early stages of Parkinson's disease to slow the disease down as best you can. What are the known environmental causes of Parkinson's disease? Well, there are neurotoxins in the environment. Most of them are pesticides and herbicides. People that are exposed to these at higher rates, like farmers as an example, tend to have higher rates of Parkinson's disease. People who live on golf courses where they spray all the pesticides and herbicides tend to have higher levels of Parkinson's. It's not funny, but that's how it is. People who retire down in Florida and they want to live on a golf course, they might want to think twice about this. But what's happening in this situation is that these herbicides and pesticides like the MPTP and rotenone and paraquat, they actually damage, if you can see my mouse, they're damaging the complex 1 in the mitochondrial chain. So the mitochondria can't transport the electrons down the cytochrome chain to make ATP energy. And if you can't make ATP energy, the cell's going to die. And also those electrons, if they can't go down the electron transfer chain, I keep losing my mouse here. If they can't go down, the electrons leak out and they form these free radicals, superoxide anion and hydrox and peroxides and hydroxy radicals. Now you'll see down here that superoxide dismutase and glutathione play a very important role in quenching these things. Now, if you don't make glutathione very well, then you're going to end up with even more free radical damage. So people that have glutathione polymorphism are at risk for this, but all of us have less glutathione as we age. Now, you can get it back, but you need to be aware that you're losing it as you get older. So that's a main factor. So just to quickly review, um, when you break down carbohydrates like glucose down to pyruvic acid and glycolysis, then of course the pyruvate is going to cross into the mitochondria, and with pyruvate dehydrogenase, it becomes you get converted to acetyl coenzyme A and then to oxaloacetate with acetyl coenzyme A forms citrate. And then, of course, as these intermediates go around in the Krebs cycle, all that's really happening, just to review, is that niacin and FAD are grabbing the hydrogen electrons, putting them in the electron transfer chain, and as they go down the cytochromes in a sort of step-down transformer, you're making energy. So in order to get pyruvate into the mitochondria, remember you also need alpha lipoic acid. It's a cofactor for pyruvate dehydrogenase. So as you age, as your alpha lipoic acid levels drop, number one, you make less energy to begin with because less pyruvate can get into the Krebs cycle. And secondly, alpha lipoic acid is a very important antioxidant that protects the mitochondrial membrane. So that decline in alpha lipoic acid is very, very important. So other things that cause Parkinson's disease, just the aging process, there's accumulation of free radical damage in all of us as we get older, and there's an accumulation of mitochondrial DNA damage in all of us as we get older. So you want to try to, in my view, you want to guard against that with CoQ10, alpha lipoic acid, and glutathione. Traumatic brain injury is linked to Parkinson's disease, risk factors for cardiovascular disease, metabolic syndrome, so a pre-diabetic condition. People who have depression or have a higher risk, people who have had drug addictions, higher risk, alcohol consumption increases risk. So there's a great review article on that you see here at the bottom of this slide if you want to go and review that. I'll make sure you get all these slides. The other thing is that metformin, which is a diabetic drug, which is a great diabetic drug, and it even has anti-cancer properties. But unfortunately, metformin damages complex 1 in the mitochondria. And we see from this large 12-year study following over 9,000 type 2 diabetics, the ones that get metformin for the management of their diabetes, they have more than double the risk of Parkinson's disease and dementia. So by damaging complex 1 in the mitochondria, you set yourself up for Parkinson's and other neurodegenerative conditions. So as great a drug as metformin is, and I really like it, it increases the risk of Parkinson's. So anyone on that drug should, at the very least, be taking CoQ10 to help protect complex 1, as we will talk about. I've given you 2 more slides if you want to get more into the weeds on the pathophysiology of Parkinson's, what's happening at a cellular level, on a molecular chemical level. It's all here on these 2 slides with that reference. And be aware also, you see here, I bolded this, but also the dopamine transporter system also becomes an important factor. So as the dopamine neurons secrete dopamine, so often that dopamine gets reabsorbed back into the the nerve cell that secreted it through these dopamine transporters, which helps to maintain your dopamine levels. But as you get older and from free radical damage as well, those dopamine transporters start to become dysfunctional. So now the cell is losing dopamine, not just because it can't synthesize it as well, because it can't reabsorb it as well. Anyway, this is a great summary paper, but we only have so much time to go so deep into the weeds on the pathophysiology, but you get the gist of it. So what is medical treatment? Medical treatment is aimed at the appropriate time, trying to increase the levels of dopamine. But you'll notice that they don't give Parkinson's patients L-DOPA. So if you give someone L-DOPA and also a decarboxylase inhibitor, then that L-DOPA will get to the brain. And the brain will convert L-DOPA into dopamine. But they don't do that right away. And the reason they don't do it right away is because when the nerve cells use dopamine, they then break the dopamine down after they used it into these metabolites that are these sort of quinone free radicals. And those free radicals actually damage the nerve cells really badly. So by giving L-DOPA to a Parkinson's patient, in the short term, you help to stabilize things. In the long term, you're giving the nerve cells a greater amount of free radicals from which they're going to end up causing even more damage and lead to the ultimate demise of the patient. So dopamine treatment is postponed until the person really needs it badly. That's why they don't give it to them in the beginning. So you're saying, well, how does all of this work? Here's how it works exactly. And this is happening in all of us, not just Parkinson's patients. But when dopamine gets broken down by the MAO enzymes, the monoamine oxidase enzymes, it forms these quinone free radicals, which cause mitochondrial dysfunction, increase the synthesis of S-nuclein, inhibits the dopamine transporters. It creates even more free radical damage in the form of oxidative stress, and you cause lots of nerve damage. So how come we're not all developing Parkinson's disease? And that's because most of us can make enough glutathione to quench those free radicals. But in people whose glutathione levels are low, or they have glutathione polymorphism that they inherited, or they don't have, or their CoQ10 levels have dropped precipitously in that part of the brain, their alpha lipoic acid, they're highly susceptible to this kind of damage and they get Parkinson's disease. That's how it works. So it's all laid out beautifully in all these research papers that are largely ignored by the medical profession. But ultimately, what's happening is that, of course, tyrosine, I'll review this in a moment, but tyrosine becomes L-DOPA, dopamine becomes dopamine, and then the MAO enzymes break it down to this product, which we just call dopal. And dopal tends to produces quinones that cause all kinds of free radicals that end up damaging the nerve cell membrane and stimulates the synthesis of synuclein. So if you can quench these free radicals before they do damage to you, you're probably not going to develop Parkinson's disease, but the aging process alone sets you up for it. That's why 20-year-olds don't develop Parkinson's disease, but somebody 50, 60, 70, they're at higher risk because as part of the aging process, your CoQ10 is dropping, your alpha lipoic is dropping, your glutathione levels are dropping, and your dopamine system is starting to fail. You can counter all of that. So here's all the research on the auto-oxidation of dopamine to quinones and how it causes nerve cell death in the substantia nigra. The evidence is convincing and overwhelming. Medicine doesn't have an answer for this, but natural medicine does, and it's ignored. So it's generally accepted by the scientific community that mitochondrial dysfunction, alpha-nuclein aggregation, dysfunction of protein degradation, oxidative stress, and neural inflammation are involved in neurodegeneration. And at the heart of it is dopamine being oxidized to these quinones that end up causing a lot of this dysfunction. So you can read about that in the Journal of Neurochemistry, published in 2014. So all these toxic effects of dopamine as it gets broken down into these quinone free radicals leads to all of these things. And the research on this is just compelling and highly verified by all sources. So the question is, what can you do for your patients to make a difference, to help improve early stage Parkinson's? Because once it gets past a certain stage, these things aren't going to work. But in the early stages, they're very helpful. I know that because I've seen a lot of Parkinson's patients. Also, what can you do to help your patients prevent the disease? And how can you prevent it in yourself and your own family members? I've seen chiropractors who are associates of mine develop Parkinson's disease, and they came to me after the fact and said, weren't you listening to me, 15, 20 years ago when I showed you? Yeah, I saw it. It looked interesting at the time. Really didn't do anything about it. Here's what you can do about it. Preserve your complex 1 functioning of your mitochondria so it can make ATP energy and not generate free radicals. And at the heart of that is stopping the decline in concentrations in the brain of coenzyme Q10. And I say that for 2 reasons, because CoQ10, as many of you know, is required to transport the hydrogen electrons from NAD. Remember, NAD picked up the hydrogen electrons in the Krebs cycle, and it's the first step in making energy aerobically. And so the CoQ10, as you see right here, is transferring the electrons down from cytochrome 1 to 2 and then to 3 as well. And preserving that function is at the heart of maintaining normal ATP production, so that you make ATP and very few electrons leak out of the system. The second thing is that CoQ10 is also a fat-soluble antioxidant that protects the mitochondrial membrane from free radical damage. So that's critically important. So you say, well, are there any real studies on this? Yes. If we go back in time, we see that Schultz demonstrated that Parkinson's patients have low platelet levels and blood levels of CoQ10. And then Beal showed that in a study of mice who are exposed to the herbicide, pesticide, MPTP, which we know damages complex 1, if he gives them CoQ10, it protects them from the damage done and they don't develop Parkinson's. But the ones that don't get the CoQ10 develop the Parkinson's disease. And then Matthews showed that oral supplementation of CoQ10 in rats resulted in higher levels of uh, CoQ10 in the brain. You can get CoQ10 into the brain by taking supplements. And then Clifford Schultz says, well, I wonder if Parkinson's patients can actually handle high doses of CoQ10. He showed that not only could they handle it, but in this study of early stage Parkinson's patients, he gave patients different doses of CoQ10 versus zero. They gave some just no milligrams. Some got 300, some got 6, some got 800, some got 1,200 milligrams. And they showed that not only was it safe and well tolerated with no side effects up to 1,200 milligrams a day, that's a lot of CoQ10. But the people who got the CoQ10, less disability. It helped to manage they got better outcomes in terms of slowing the progression of the disease. And the higher the dose, the greater was the effect. So in a dose-dependent fashion, these people saw an improvement. So what happened since 2002 when that study was published in the Archives of Neurology? Well, it's not just CoQ10 that's helpful. That's what we now realize. CoQ10 is part of the story. Unfortunately, Dr. Clifford Schultz, who was a researcher at the University of California in San Diego, died of cancer at a young age in, I should say, 2007. And no one has picked up on his work. It's just been left there. No one's touched it since then. So all the work on CoQ10 halted. And so it's very interesting. I sometimes see Parkinson's patients who are being managed by a naturopath, and they sometimes leave out the whole CoQ10 part of the story. It's critically important. So you need to be another set of eyes on this system. But the evidence is overwhelmingly, verifiable that when CoQ10 levels drop down, and complex 1 can't work well. Electrons leak out, they form free radicals. Not only do you get more free radicals, but it leads to mitochondrial dysfunction. So now the mitochondria can't reproduce themselves normally. You can't get mitochondrial biogenesis. And mitophagy. Mitophagy is when you take some of the mitochondrial parts that are being broken down are still usable. The body will reuse the good parts and build new old parts so that the mitochondria is working perfectly well. And without CoQ10, that's not going to happen. And also, as those free radicals build up, it leads to more accumulation of synuclein, which is the toxic protein that causes nerve cell death and leads to Lewy body dementia. This complex 1 story is critically important. Medicine has absolutely no drugs to address this, so they don't talk about it. And here's the decline in CoQ10 as you get older. By age 40, if you and your patients aren't taking a CoQ10 supplement, you're asking for trouble. In your brain, the heart muscle needs it. You end up with congestive heart failure in many cases. Your blood pressure starts to rise as you get older, your blood pressure rises. It doesn't have to. CoQ10 is also required for the synthesis of nitric oxide for endothelial function. So you need to get that CoQ10 back, in my opinion. Remember that CoQ10 is not only important to transfer electrons down the cytochrome chain to make ATP, but it also protects the mitochondrial membrane from free radicals because it's a fat-soluble antioxidant. It also increases nitric oxide release, so you have better endothelial function to help keep blood pressure controlled as you get older. So from a prevention standpoint, taking CoQ10 by age 40 or 45 at the latest may help prevent Parkinson's disease, congestive heart failure, high blood pressure. It supports immune system function. Studies have shown that it improves chronic obstructive pulmonary disease and may help prevent lung fibrosis, which is an important cause of death as people get older, and also may help prevent dementia, as for reasons that we're seeing here today. So CoQ10 is an important part of the nutritional medicine story. Here's the next part. The decline in glutathione that occurs as you get older. Look at the decline in glutathione that you have in your body, which is the critical, important antioxidant to mop up those dopamine quinones. hope you're following me. It's so hard to teach a webinar when you can't see the eyes of the audience. But the decline in glutathione in aging reduces the ability of dopamine-producing neurons to quench dopamine quinone-free radicals, which can accumulate and trigger cell death through apoptosis and synuclein aggregation tied to cell death and Lewy body dementia. Some people are born with glutathione transferase polymorphism. That means that they can't make glutathione very well. In this situation, it's very smart for these people to get glutathione. If there's Parkinson's disease in somebody's family, they should, by age 35 or 40, start getting at least once a month glutathione infusions from an integrative cancer doctor or a naturopath. We'll come back to this. But the other thing to know is that oral supplementation with N-acetylcysteine can raise glutathione levels. And because your glutathione levels are dropping as you get older, and all of us, we should all be by age 40, in my opinion, taking some N-acetylcysteine to help preserve that, something that I have done. Here's all the research on it. Not just pulling this out of thin air. It's not from, Prevention Magazine. This is serious peer-reviewed stuff showing the importance of glutathione polymorphism in risk of Parkinson's disease. Then in 2019, this is a breakthrough study. As outlined in 2000, it was first, I don't know why it says 2019, because in 2021, this study appeared in the International Journal of Molecular Science that showed that a decline in glutathione, brain glutathione in the aging process has emerged as a significant factor in various neurodegenerative diseases, not only Parkinson's, but also Alzheimer's disease, Lou Gehrig's disease, all these things you don't want to develop. That age-related decline leaves cells vulnerable to free radical damage. We know that. The 2019 study in the Journal of Clinical Pharmacology showed improvement in symptoms of Parkinson's disease when patients were administered N-acetylcysteine. So NAC is the amount of cysteine available is the rate limiting step and how quickly the cells in the body can make glutathione. So if there's enough N-acetylcysteine, or really just cysteine, but NAC is the way to get it there in the acetylated form. But when cells have enough cysteine, usually they can make lots of glutathione unless there's glutathione polymorphism, but that's a very small percentage of people. For most of us, if we have enough cysteine in our cells, the brain and other cells in the body will make optimal amounts of glutathione. So they say, well, okay, let's take 42 Parkinson's patients, let's give them N-acetylcysteine infusions and also give them oral supplementation of N-acetylcysteine. So you see the doses for 3 months. The placebo group just got the standard Parkinson's treatment. The results showed over the 3-month period, the patients receiving N-acetylcysteine treatment saw improvement in their overall Parkinson's disease symptoms. And brain imaging showed that glutathione levels were increasing in the brain, and there was significant improvement also in the dopamine transporter. That means that now the nerve cells are after dopamine gets secreted into the synaptic cleft, rather than it all being broken down by the MAO enzyme, much of it gets reabsorbed by the presynaptic nerve cell and gets stored in the vesicle so it can be reused again, helping to preserve normal dopamine levels in the nerve cell itself. That dopamine transport is very important. So what does it mean? As Parkinson's disease progresses, the dopamine transporter, which pumps dopamine back into the nerve cells from the synaptic cleft, typically becomes less and less active, leading to further depletion of dopamine. A lot of your dopamine levels are dependent on the dopamine transporter to transport it back into the cell after it's been released. So the administration of N-acetylcysteine is the only known biochemical that's been shown to actually improve the dopamine transporter. Now, I want to tell you something else. Doing regular aerobic exercise has also been shown to improve the dopamine transporter. So exercise and NAC are the two things you can do naturally to help preserve your dopamine transporter. And if you can do that, even in Parkinson's patients, they tend to show improvement. But we all should be aware of that for prevention. So the study suggests that N-acetylcysteine treatment not only helps to increase brain levels of glutathione, but it also improves function of the dopamine transporter, helping to optimize brain cell levels of dopamine and hence to reduce tremors and improve balance and coordination and other features of the disease. I don't know any neurologists in Toronto that recommend N-acetylcysteine. I haven't seen this anywhere. Maybe I'm just missing something, or I'm just not in touch with the real world, but I know Parkinson's patients who I speak to personally. None of them have told me that their neurologists recommend that they start taking supplements of NAC and doing infusions of NAC. So here's additional research on the role of these things and how the dopamine transporter works. Critically important for the functioning. Here's N-acetylcysteine and Parkinson's disease research. I've read all these papers. It's mind-blowing. And it's just makes you sad to see how much of this is being ignored. Then in the year 2021, they did a whole meta-analysis of where they've actually used glutathione as a treatment for Parkinson's disease, using glutathione supplements. Now, let me tell you something. Glutathione is a tripeptide. It's made of, L-cysteine and glutamine and glycine. Though that tripeptide, even though it's only 3 amino acids, doesn't get absorbed very well. So the bioavailability of taking glutathione orally is not really that good. It's much better if you're going to use glutathione to do it via an IV or sublingual. So this is just oral supplementation. They just reviewed all the studies and they said even in the cases where glutathione was taken as a supplement, which doesn't even get absorbed that well, in these 450 patients that we have, we're saying it actually helped to improve muscle function and movement function and reduce tremors. So even just taking glutathione alone has been shown to be helpful. And why is that? It's blocking damage around the mitochondria by quenching these quinone-free radicals. It's pretty straightforward. So glutathione treatment not only helps to reduce the symptoms of Parkinson's disease, but also helps to inhibit steps involved in the underlying cause of the disease, which is free radical damage to the substantia nigra cells, which are dopaminergic producing neurons. That's why Parkinson's is, why is it the dopamine producing neurons? Why are they dying and not the other cells in the brain? Because they're the ones making dopamine, and dopamine gets broken down into these quinones, which cause free radicals. If you can block that process, you're blocking the disease process. But the problem is noted by many researchers that glutathione supplements are broken down in the intestinal tract. They don't reach the bloodstream very well. Glutathione doesn't even cross the blood-brain barrier very well. So the thinking is that using N-acetylcysteine is actually superior. The best way to raise brain levels of glutathione from oral supplementation is with N-acetylcysteine, or they're in the development now, which I might share with you down the road, but a particular sublingual glutathione that gets dissolved through the oral mucosa right into the bloodstream may also be a secondary factor of importance. It doesn't replace using N-acetylcysteine, but it may be an additional thing to do. But N-acetylcysteine has been shown to be absorbed intact. It enters the bloodstream and it easily crosses the blood-brain barrier, and it's been shown to actually raise glutathione levels by 55% in a very short period of time. So here are the references for that. But in terms of showing the elevation of glutathione in the brain very quickly after N-acetylcysteine supplementation, that would be reference 3 that you see here in the International Journal of Molecular Science in 2021. So what do I think you should do? I think for glutathione, that strategy, I think you should take 1 or 2 capsules a day, as I do, of Adeeva Ultimate GLX, because what I put into that formulation is not only N-acetylcysteine, but also alpha lipoic acid, which is also declining as you get older, and silymarin and L-glutamine. These 4 things have all been shown to raise glutathione levels. And remember, the alpha lipoic acid is also protecting the mitochondrial membrane with CoQ10, and it's helping to generate more energy by affecting pyruvate dehydrogenase, so you can make more oxaloacetate into citrate and more intermediates in the Krebs cycle. And also the thing to know, as I said earlier, is that alpha lipoic acid synthesis in the body declines with age, and I've given you the scientific reference on that. It's not just speculation. In Parkinson's patients, what I have done with them is I give them 4 capsules a day of Adeeva Ultimate GLX, and then I schedule them for glutathione infusions and N-acetylcysteine infusions. So the doctors that I've used over the years, I got them to agree to do this because they saw the patients were benefiting, is they get a 1,000 milligram IV of glutathione that's infused slowly. Then after that's done, there's a flush, and then they infuse them with N-acetylcysteine, sort of like a double hit. And if they do that every 2 weeks and the Parkinson's disease is not too far advanced, often it helps to really, really manage the condition. Well, it's not a cure, but it does help to manage it, slow the progression of the disease. In patients with a family history of Parkinson's disease, I think you should be giving them at least 2 capsules of Ultimate GLX every day. And at least once a month, they should consider getting an infusion of glutathione or NAC. They may have inherited the glutathione polymorphism genetic uh, factors that don't allow them to make glutathione properly. So if you infuse it or you help them produce more glutathione, it may actually help them significantly. The other thing that I want to mention is how do you counter the decline in dopamine and dopamine signaling? So dopamine levels decline around 10% per decade, starting in early adulthood. And it leads to changes that you see in aging, everything from, decreased cognition, motor performance, reflexes, even libido can be affected, sexual arousal can be, climax ability can be affected. So dopamine is required also for motivation and reward behavior. It's multi-dimensional and also in the prevention of depression. So I'm just going to point this out to you that there's an herb called the Mucana pruriens, also called the velvet bean, which just happens to be a rich source naturally of L-DOPA. Right. So you can find L-DOPA products or mucaniprurins products in the marketplace that are standardized grade of L-DOPA to help maintain your dopamine levels. We'll come back to this. But aging is associated with widespread changes in the dopamine signaling. You have a loss of dopamine neurons. Hopefully you can prevent that with glutathione, alpha lipoic acid, CoQ10, exercise. But there's also a decrease in dopamine receptor binding and loss of dopamine transporters. As I said, exercise can help preserve that, and acetylcysteine can help to preserve that. This decline, but in most people who don't take those steps, the decline results in an average loss of the D2-like receptor concentrations in order of 9% per decade. Even without Parkinson's disease, 25% of older adults have striatal dopamine transporter binding threshold that are 3 standard deviations lower than that who's younger. So if you wonder why your reflexes aren't quite as good, or you're not living in any kind of doing any risky things with your life anymore, and your reward motivation system seems to decline as you get older. One of the reasons might be your dopamine signaling is not working that well. And you can't get it all back, but I'm going to show you how you can preserve it to some degree. So that dopamine tone becomes very important to movement and reflexes and balance and everything else. So just to review, because you know this, but you may have forgotten some of it. Then we have certain foods that have proteins, and some of those proteins will have amino acids like phenylalanine and tyrosine, and they can be converted into L-DOPA. Huh? And in order to do that, this is folic acid that you need for these two conversions. And then L-DOPA becomes dopamine. You need vitamin B6 and magnesium to do that. That's why a multivitamin can be also helpful. And remember that dopamine can also make norepinephrine and epinephrine, which are important neurotransmitters as well. But here's where dopamine gets broken down by the monoamine oxidase to dopal, which generates all these free radicals. You want to try to quench these free radicals as best you can. But the decline in the dopamine receptors can be very significant and troublesome. So here you see the decline in dopamine receptor function and dopamine transporters as you get older. It's just a fact of life. What I think you should try to do is slow down that loss as best you can. I've given you this diagram showing the synthesis of dopamine in the nerve terminals that gets stored in the vesicles, and then it gets released upon stimulation. It stimulates the dopamine receptors of the postsynaptic cells. And then some of it through the dopamine transporter gets taken back up and put back into the vesicles. That's in a perfect world, but as you get older, that system starts to break down a little bit. So this study sort of just shows the decline in dopamine receptors of the different types as you get older. And this is, again, just showing how the dopamine transporter pumps the dopamine back into the cells so they can be reused again and stored in the vesicles and then resecreted. If it doesn't get taken up, then the enzymes will break it down into these free radical components. And you see there's different types of dopamine receptors in different parts of the brain. There's the D1, D2, and D3 receptors. If you want to read up on that, there's a great research link here to help give you more details on it. So back to the mucaniprurins or the velvet bean. This is a product that I now take. It's made by Now Vitamins. It's available in Canada. Also, it's actually an American product, but you can get it in Canada. And other companies have similar things. But it's standardized to 15% L-DOPA content. So if you take two of these capsules a day, then you're getting 120, you're getting 240 milligrams of it. Let's just use one capsule as an example. So in one capsule, if it's 800 milligrams of the herb material, standardized to 15%, you're getting 120 milligrams of L-DOPA per capsule. What we know from bioavailability studies is that 2% of that L-DOPA in each capsule will ultimately cross the blood-brain barrier and can be used to make dopamine. So that's about 2.4 milligrams of that capsule. L-DOPA will actually reach the brain. If you take two capsules a day, it gets you up to almost 5 milligrams. Remember that the brain is only making micrograms a day of dopamine. It's not making large concentrations. So that's actually a lot of dopamine for your brain to get access to, that as you get older, it normally starts to run out of dopamine. But remember that if you're going to give your brain access to more dopamine, as it gets broken down, you're going to make more quinones. So you better have enough glutathione there to quench those quinones. So you wouldn't take this product unless you're taking N-acetylcysteine, or I would suggest you use Adeeva Ultimate GLX to maximize your glutathione concentration so you don't let dopamine damage your brain while it's preserving your muscle integrity and cognition, sexual arousal, all these wonderful outcomes that you might want to try to maintain as you get older. So these are the glutathione precursors, N-acetylcysteine, alpha-lipoic acid, silymarin, and glutathione. I put them all into one formula called Adeeva Ultimate GLX. But I want you to know about this other company. For people with Parkinson's disease that I have seen, they sometimes go to CHK Nutrition, which you can find on the internet. And there's a MD there, Marty Hintz, who actually created a mucannapurines powder, because of Parkinson's patients, if they who don't want to use drugs, they sometimes will use this powder. And the powder, they take lots of powder and they mix it into sort of a fluid drink. They can get the equivalent amount of L-DOPA as they would get from their medication, but it's from natural source. But even in those cases, I encourage those people to take N-acetylcysteine, CoQ10, use Adeeva Ultimate GLX, get infusions, on a twice a month basis of glutathione and NAC, which a lot of naturopaths actually do. You can find naturopaths who are doing this. So there's some great studies on the consumption of ecannabinoids proving that it can actually raise brain levels of dopamine. So the herb is the real deal, but it needs to be a standardized grade. And it can have all these sort of secondary benefits that we sort of talked about. And the herb seems to have other neuroprotective properties that just giving people L-DOPA doesn't have. Uh, One of the things they realized when they started giving Parkinson's patients, if they give them levels that are too high in L-DOPA, or they used to give them dopamine agonist drugs, which they've taken off the market, because if you overstimulate the dopamine system too much, people develop these like hypersexuality syndrome, where they start seeing they start doing things they normally wouldn't do, seeing prostitutes, they go gambling, they bet the house, they go to the racetrack, they go to the casino, things that maybe they didn't do before, because their dopamine reward system is like cranked up to a point where it's changing their behavior. So they took those dopamine agonist drugs, they actually took them off the market, and they just try to get the right L-DOPA level. But using Mucannapurines can also produce some of these effects, not to the same degree unless you took like some crazy dose. But understand that dopamine is modulating the key areas of the reward system, including the nucleus accumbens, which is tied to sexual arousal. So it can also be used to help get people's interest back into sexual functioning, in case that's of interest to you as you get older. And this is just showing some of those connections from the basal ganglia to the ventral tegmental area, which is the pleasure center in the brain, and how it reaches these other things. So when you stimulate that dopamine system, there's more dopamine available for the pleasure centers. And from there, sexual arousal can be more easily triggered, and also pleasure from orgasms is even greater. So men and women lose some of that youthful functioning as they get older. So what I'm saying is preserving your L-dopus, your dopamine system, can help to preserve some of these functions. But dopamine, of course, is it's not just sexual functioning that you release dopamine. If there's a food that you like, that releases dopamine. If you like listening to certain kinds of music, that releases dopamine. Even charity work or, playing, going gambling, not just winning, but also the anticipation that you might win gives people a dopamine rush. That's how people get addicted to some of these things. Even teaching webinars online like this, it's hard as it is to prepare for it. Teaching it is actually a dopamine rush for me. I enjoy it. The thing to keep in mind, though, is that because dopamine also can become norepinephrine and epinephrine, which stimulate the sympathetic nervous system. It can also increase the heart rate and blood pressure and cause palpitation. So if you have too much dopamine being produced, you're going to get more norepinephrine and epinephrine. And so people that have cardiac risk factors should probably avoid overstimulating that system. So if that's the case, and using mutanoprurins is probably not a good idea. So what are the overall goals as we start to wind down for people with Parkinson's disease? Where can you help them? You want to help optimize or restore their mitochondrial function, increase ATP synthesis within their neurons, block free radical damage, help them maintain memory and cognition, increase their dopamine synthesis if they're not already on medications, address sleep issues, customize an exercise program, and try to teach them cognitive movements that sort of bypass the basal ganglia. So how do you do that? How do you help restore mitochondrial function? CoQ10 is the main thing. CoQ10, that's what they need. You want to increase ATP synthesis, they also need CoQ10 for that. And creatine monohydrate is also helpful. There are some studies on giving people NADH tablets or infusions. You can read about that. I've given you the link. You want to decrease free radical damage? CoQ10 does that. Alpha lipoic acid does that. Taking a high potency multivitamin like the Adeeva multi does that. Why? There's 1,000 milligrams of vitamin C, 400 IUs of vitamin E, 200 micrograms of selenium to help make glutathione peroxidase. These are important antioxidants that all cross the blood-brain barrier, get into the brain, and serve as antioxidants. And acetylcysteine, of course, is important to quench free radicals because it helps to make glutathione. There's also vitamin D receptors in the brain that are important. Melatonin acts as an antioxidant in the brain. Selenium helps to increase glutathione levels. Drinking green tea, the EGCG, epigallocatechin gallate in green, crosses the blood-brain barrier. It's also a very important antioxidant. Glutathione infusions and N-acetylcysteine infusions, these things are all very important to include in the protocol for patients with existing Parkinson's disease who still can have their disease affected. If they're too far down the road, it's not going to work. You want to help maintain memory and cognition. CDP choline has been shown to do that very well by increasing the brain chemical acetylcholine, but CDP choline has also been shown to raise dopamine levels. So in our Adeeva memory support complex, remember CDP choline is already present there. Omega-3 fats also help with memory and cognition. I like people to take some lecithin capsules every day, as I do, 2 of them a day, to get additional choline available for the brain. And the Adeeva multi, with its antioxidants and its B50 complex, helps the brain make neurotransmitters and quench free radicals. Other things, so again, that CDP choline is important because it helps to also increase dopamine synthesis, as does a high potency multivitamin because of all the different B vitamins, and also vitamin B3, which is critically important. How do you address sleep issues? Well, melatonin alone can do that, or Adeeva Sleepy Naturals. There's exercise programs that are targeted to Parkinson's patients that work very well. And an ex-patient of mine named Dr. Norman Deutsch, who's a psychiatrist, very famous guy now, wrote a book called The Brain's Way of Aging. He has a fantastic chapter on Parkinson's disease and how teaching the person different movements can actually help to slow the disease process down. So here's references on all that stuff, including creatine, which we didn't get to earlier. A great 2017 study showed the benefits of endurance exercise in Parkinson's, the benefits of strength training in Parkinson's disease. And here's the book, The Brain's Way of Healing by Norman Deutsch in chapter 2, He has a chapter called "A Man Walks Off His Parkinson's Disease." Really, really worth reading this book. Norman's a great guy, and the book is sensational. Study in 2022 showing that when you do aerobic exercise, muscles release a molecule called irisin, and irisin gets into the bloodstream. It crosses the blood-brain barrier. When it does that, it actually blocks the buildup of synuclein and helps to encourage the breakdown of synuclein. So that's what this is basically saying is that if you do aerobic exercise, you can help to prevent accumulation of synuclein to some degree. You can help to break down synuclein that you may have already accumulated, and it increases the action of the dopamine transporters to help preserve that dopamine signaling system. Critically important, aerobic exercise. So this is sort of the summary of the nutritional protocol for people that already have Parkinson's disease. I sort of laid it out here on this one slide, and I just sort of covered it already, but here's a one-page summary. I would also encourage them to get infusions of glutathione and NAC, as I outlined for you. A lot of naturopaths do this, and some integrative medical doctors do this as well. But just in terms of anti-aging for the rest of us who don't have Parkinson's disease yet, I think what's important to realize is that there's that decline in CoQ10 and alpha lipoic acid is very important because you decrease ATP synthesis and you allow more free radicals to build up in the cells. The decline in dopamine synthesis is also very important. You start to see as people get older, there's decreased arm swing and as they walk and they start walking more slowly. All these things are indicators that the dopamine system is starting to break down. You also want to preserve that decline in memory that can occur as you get older, and you want to preserve your substantia nigra. Don't wait for tremors to occur. By the time tremors occur, 60% at least of your cells are already dead in your substantia nigra. Why are you waiting? So on a preemptive level, because Parkinson's disease is the leading movement disorder of humans, and patients with a family history of Parkinson's disease who don't have the disease yet, this really becomes critically important for them. But I think all of us should consider by age 45 or 40 taking a CoQ10 supplement. I use Adeeva Cardio Essentials. At this age, I take 3 capsules a day. That gets me 90 milligrams of CoQ10, but it's also giving me some other things that are important for heart function. I think N-acetylcysteine by age 40 or 45, I take it as part of Adeeva Ultimate GLX because it has the other factors like alpha lipoic acid. And Adeeva memory support by age 55 with the CDB choline and other things to maintain memory function. By age 55 or 60 at the latest, you might want to consider mecanoprurins using 1 or 2 capsules a day standardized, but make sure you're getting enough glutathione precursors to quench the quinones, otherwise you might be causing some damage to yourself. And I think creatine monohydrate 5 days a week is a smart idea as you get older as an anti-aging intervention for your muscles and for your brain. Along with the Adeeva high potency multivitamin, essential fatty acids, regular exercise, endurance, and strength training. These are really important prevention strategies that I think are part of healthy aging to preserve your functional life as you age. Some of the things I mentioned in this, here's the Adeeva Ultimate GLX. In case you're not familiar with it, you can go online and learn about it, but it has those precursors to make glutathione, specifically N-acetylcysteine, alpha lipoic acid, silymarin, and L-glutamine. This is our sexual enhancement product, Sensogen, in case you don't know about it, that is used to help preserve libido and sexual responsiveness and performance. If you haven't tried it, you might want to think about it if you think you could benefit from it. And here's the Dopa Mucana product that I use, 1 or 2 capsules a day. So the Adeeva supplements that I featured in this presentation, just to quickly review them, is the Adeeva Multi, the Adeeva Memory Support Complex, Ultimate GLX, Cardio Essentials, Sleepy Naturals, and in case it's of interest, also Sensogen. But that's really the lay of the land in the Parkinson story that's being highly ignored. Helping to preserve complex 1, quenching those free radicals, helping to enhance the dopamine signaling system as you get older, giving people exercises to do, and preventing inflammation, giving the brain the nutrients that it needs to function more optimally and make neurotransmitters. That's critically important. No one talks about it. No one talks about it. It's absolutely very sad. So I'll make sure these slides are available to you. Thanks for sitting in. Greatly appreciate it.